Hey Algebra 2ers, welcome to lesson 113. Okay, it's not that I'm trying to scare you or say, oh, this is the hardest lesson ever. But I also wanted to say that it's the easiest lesson ever because it's not, okay? But look, it's just that it's using terminology that we don't usually use, okay? We're learning the lesson today of logarithms and anti-logarithms. Now, if you stop and read this lesson, it's going to tell you that everybody gets scared about using these terms, logarithms and anti-logarithms, okay? So look up here, I wrote logarithm and anti-log. And then I gave the synonyms to those, the definition of those, okay? Logarithms are just another word for exponent. And anti-logarithms are just another word for the number, the answer of taking a number to the exponent, okay? So first, bit by bit, byte by byte. Let's remember that part first, okay? Logarithms are just an exponent. Anti-logarithms are just the number that you get after getting an exponent. So first, after you understand that, the definitions here, logarithm, exponent, anti-log, number. Now you need to make sure you have your calculator. You need to make sure that you have your calculator because we're going to be using buttons on this calculator. Let's say that I put in log 100. So we go to our calculator, we put in log, that right there, L-O-G, 100. And you get 2. Well, what does that mean? That's great that we put in our calculator. It's great that we get 2, but what is that? Okay, your answer is 2. What that is saying is that, look, logs can have the base of anything. There's really a number here that's invisible, okay? That's a circle and a 0. It can have the base of anything, but really you're only going to see the base of 2 different things. The first one you're going to see the base of is 10, okay? So on your calculator here, automatically your log is base 10. Okay, your calculator is programmed to have the log as base 10. So what does that mean? It means that, look, when you put in your calculator log 100 and you get the answer as 2, behind the scenes, it's telling you that 10 to the 2 equals 100. So this right here is your log. And this right here is your anti-log. Okay? So, because this is the number and this is the exponent. So that's what's happening behind the scenes. When you put in log 100, you're really asking the calculator to find 10 to the what equals 100, okay? Well, you can put it in for any number. Let's say that is log 4, okay? So you put into your calculator log button 4, and you're gonna get 0.602. So that means that 10 to the 0.602 equals 4. That's your logarithm. This is your anti-log, the 4. Okay? Now, you can also go the opposite. Like, let's say you want to find the anti-log. Meaning this. What if you do, you want to know the anti-log of 2. Which that means, what are you asking? You're asking to go 10 to the 2 equals what? This is your x. So we know that log 100 equaled 2 because 10 to the 2 equals 100, right? So now if you do anti-log, now you're finding that this is your exponent. What is the number that it produces? Okay, which is just 10 to the 2. And honestly, in your calculator, you could just put 10 to the 2, but they give you an option to do anti-log, which is your yellow button above the log. So you go shift, oops, pardon, you have to put in the 2, pardon. No, you do this first. Shift, log 2, 100, okay? Which means that 10 to the 2 equals 100. That's the anti-log of 2. So if we want to do the anti-log of 7, okay? What are you really doing? You're doing 10 to the 7th, okay? which means that you can go over here, do shift log 7, and your answer is 10 million, okay? And to prove that that's just the opposite of log, what if you do this? What if you do log of this answer? Log of this answer should give you 7, right? And it does. Because now you're asking, okay, log of this, you're asking 10 to the what equals this. And your calculator is going to tell you 7. Okay? So I told you there's 2 bases that you normally see. So what's the other base? You have log base 10, that's normal. If you put it in your calculator as log, you're going to get base 10. But now there's something called natural log, which has an ln. Find it on your calculator. ln. Right there, right by log, there's an ln. Which even though it has the L in front and the N in the back, is a natural log. So what is this? This is also log base E. Base E. This is used in calculus. This is used in all advanced math, okay? So look, you have this natural log 100. What that really is, natural log 100, is log base E. So I'm just going to write it again so you see it, because you're going to see it like this too sometimes. Then instead of log base 10, you're going log base E 100. So what are you asking? E to the what power equals 100? Well, yes or no, the logical question first is, what is E? What does it stand for? A billion, a trillion, 3.14 like pi? What is E? Well, I can tell you very easily from your calculator. It's also in your book here at the very bottom. E equals 2.71828182885. That's on page 438. But look, you can also see it here. Here's your natural log button. Go shift E to the 1 power. So just put a 1 here. You don't have to do the power or anything like that. Just put a 1 there. And it'll tell you 2.718281828. Yep, and then 5 if they could bring it all the way over. That is E, okay, so it's not 10. It's this weird number that is used in a lot of calculus in different advanced math courses, okay? Do you need to memorize that number? No, because you can go to your calculator at any time and put shift natural log to find your E to the 1 and find your E. Okay, so when you put this into your calculator, go ahead and put this into your calculator. Natural log 100 is 4.605, right? Okay. So again, just to reiterate, what does that number mean? It means this: E to the, well, your calculator, 4.605. What were we doing today? 100, yeah, is equal to 100. So E to this power equals 100. That's what the 4.605 means, okay? They don't expect you to grasp that 100% yet, okay? Because it is abstract, it is weird, it is backwards from the way that we work. But they do want you to know how to get to it in your calculator. So now they're gonna let you play with it. They're gonna let you play around with the rules of it, because the rules of logarithms are the same rules as exponents, okay? So look at example 1. Use your calculator to get a value for E, okay? I just told you that. You go to your calculator, shift natural log to the 1. 2.718, blah, 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 blah. Okay, that's all you have to do. They're just getting you to use your calculator, so make sure you do it with me. But now look, example 2. Use base 10 logarithms to simplify this, okay? Yes, you could simplify it from your calculator, but they're trying to get you to use your logs in your calculator. So what are you gonna do? Base 10 logarithms, that's how your calculator is set up, is with logs. So what you're gonna do, just do it with me. Log 47,832. Enter. We get 4.679, so 4.68. So the very first thing, the 47,832 is 10 to the 4.68, okay? Then 59,000, blah, 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 blah. Go log 59,463 is 4.77. So now you're going to put 10 to the 4.77. Okay, you're not putting just 4.68. You're not putting 4.77. Because remember, what you're doing is you're finding 10 to the what equals that number, right? So this is going to be multiplying. And then 0.000817. So log 0.000817 is 10 to the negative 3.088, or 3.09, we're gonna say, okay? So then, what do we do? Well, what are your rules of exponents? They're the same as the rules for logarithms. When you are multiplying with the same base, you're adding the exponents, right? So here we go, 4.68 plus 4.77 is 9.45, 10 to the 9.45, over 10 to the negative 3.09, right? So then what do you do? When you're adding exponents, when you're dividing exponents like this, you subtract. So it's 9.45 minus a negative 3.09, so it's 9.45 plus 3.09. So that means your answer is 10 to the 12.54, right? Okay. Then you have to get, what is this answer? Now look at what this is. 10 to the something is called an anti-log, right? So there's two buttons you could use. Now in this case, I'm gonna be very logical with you. I'm not gonna use the anti-log button. You could. You can go here, shift 10, right? And then do 12.54. Okay, or you could just go 10 to the 12.54. It's the exact same thing, okay? Your answer is gonna end up being 3.47 times 10 to the 12. And that's your answer right there. So simplify those numbers using the base of 10. Now, look at example 3. You're gonna simplify the same numbers listed in the book using base E logarithms. And you're gonna see that your answer basically comes out to be the exact same, okay? So, go natural log ln 47832, and if you're like, Michelle, this is so dumb. No, it's not dumb because it's helping you learn how to use these functions. Natural log again, 59,463, which is e to the 10.99 over e to the what? Natural log ln to the 0.000817, natural log negative 7.11. Okay, so now let's add these together. 10.78 plus 10.99. Okay, and I'm just gonna subtract this one right away. That's a negative, so it's gonna be plus 7.11. That's gonna give you e to the 28.88, okay? And that we're gonna have to do in our calculator with the shift natural log. So go shift, natural log, then type it in 28.88. And you're gonna get 3.49 times 10 to the 12, okay? If I just wrote 3.47 to the 12 before, I really apologize, because in your calculator you can see that it's times 10 to the 12. Pare down. Okay, look at example 4. Look at example 4, because now this is where it starts to get a little bit more complicated, and I'm trying to go slow. Okay, first of all, look what it is. If negative 0.0325 equals log base E, as soon as you see that, you guys, what is log base E? It's natural log. So, write it correctly. Natural log y, okay? Then find y. So what is this asking? It's asking that e to the negative 0.0325 equals y. Okay, that's what it's asking. You have to see that. ln is base e. E to this exponent equals this y. Okay, that's what it's saying, which I taught you that before. Trust me, you're going to get used to it. So go ahead and put it in your calculator. That's shift natural log negative 0.0325. And your answer is going to be 0.968. E to this equals 0.968. Okay? Look at example 5. I'm going to do all the practice with you too because I want to make sure that you understand all of this and the different formats that you could see it in, okay? So, if you have example 5 here, y equals 4,302. Find log y. Super easy. What are you going to do? Just go into your calculator, log 4302. 4302. 3.633. That's your answer. Okay? What about natural log y? Okay, so go to natural log 4302. Hit it, and your answer is 8.37. Okay? So let's look at the practice. Find x. Remember that if we know the base, there are only two other numbers. One number is the logarithm, and the other number is the anti-logarithm. Thus, we will always use the log or natural log key, or the inverse log and the inverse natural log key, which are the shift ones, okay? So, look at letter A. Piece of cake, just put it into your calculator. I'm going to show you what you should get. You do natural log 0.0052. Your answer should be a negative 5.26. A negative 5.26. That means e to the negative 5.26 is going to equal 2.0052. Letter B. E to the x equals 51.4. Okay, so think about it. E to the x equals 51.4. Well, what are you supposed to do to find the x? It's natural log, you guys. Because and look, see if you forget. You can't do e to the x, the shift one, because you're looking for the x. So you do the opposite, which is natural log. So you go natural log 51.4. Your answer is 3.94. That means that e to the 3.94 equals 51.4. And if you're like, well, Miss Jessica, are you sure that's your answer? Well, just try it. Look, go e to the x, and then put in your answer. 51.4. So yeah, it's the way to do it, okay? You just do the opposite. Look at letter C. So natural log x, negative 4.16. I want to show this to you visually. Natural log x equals negative 4.16. Here is your e. So what are you saying? Because that's your invisible base. That means e to the negative 4.16 equals x. So that's exactly what you put in your calculator. The inverse log. Inverse natural log, pardon. So inverse natural log negative 4.16. Your answer is going to be 0.0156. Okay, 0.0156. How do you know that you're right? Well, check it. Go natural log, answer. And you get a negative 4.16. So you know that you're right. You're working with the right opposite. Letter D, log x equals negative 4.16. Again, log is base 10. So what is it saying? It's saying 10 to the negative 4.16 equals x. So I'm just going to do that. I'll do the anti-log here. I don't mind. Shift log negative 4.16. And your answer is 6.92 times 10 to the negative 5. Okay, you want to make sure that you're right. Hit log, answer. And your answer is negative 4.16, so you know that you're right. Okay? And letter E, use the natural log key to express each number as a power, then use the rules of exponents to find the answer. That's exactly like your examples here that we just did together. So let me just check one thing. If they give that one to you in the book. They do. Go ahead and try exactly how I taught you the examples. Example 3 to be exact. And then check your answer in the back of the book. If you still have questions, just let me know. Okay? That's how you do lesson 113. Don't be frustrated if you don't understand 100% because you're going to get practice on it. But if you can pinpoint exactly what doesn't make sense, what needs to be repeated again in a different way, text me and we can work on it together. Bye.